Welcome to this tutorial. In this guide, you'll learn how to create a Python application using PySide-6 for a rich UI interaction. This application uses the edge-tts library to provide text-to-voice functionalities available in Microsoft Edge. Before you begin, please ensure you have both Python and the PyCharm IDE installed. Once ready, click the New Project button to start. This window is where you set up your new Python project in PyCharm. Options here include location for setting your project's directory, interpreter type for choosing your Python environment, and type for selecting between virtualenv, conda, or other environments. Name your project edge-tts app as indicated by the arrow, then click Create. If you see a pop-up in the lower right corner about folder indexing, simply click the Exclude Folders button to optimize performance. Now, let's create the Python file where we'll implement our application. Start by right-clicking on the project's folder. Hover over the New option to see the list of file types you can create. In the New menu, you'll find options for creating different types of files like HTML, JavaScript, and more. We're choosing Python file to create a .py file, which is necessary for implementing our application in Python. While the file name isn't crucial, it's common to use main, app, or another name indicating it's the entry point. Let's name this new Python file main and press Enter. This file is where we'll write the code for our entire application. In Python projects, you can have multiple .py files organized as modules. This modularity allows you to import and use code from different files, making your project more manageable. The sys and os libraries are crucial here. Sys provides access to variables maintained by the interpreter and functions that interact with the interpreter. OS interfaces with the underlying operating system, allowing you to manage files and directories. Please type these imports into your app. The asyncio library in Python allows for asynchronous I/O operations, enabling non-blocking execution of code. This is especially useful for tasks like handling network requests efficiently. Please type this import as well. The subprocess library enables you to spawn new processes, connect to their input-output error pipes, and obtain their return codes. It's essential for managing external commands in your application. The temp file library is used to create temporary files and directories. This is useful when you need a temporary storage location that gets cleaned up automatically. The datetime module supplies classes for manipulating dates and times. The from import syntax allows you to import specific parts of a module directly, providing a cleaner namespace. For this project, we'll need two third-party libraries. edge-tts is crucial as it provides the text-to-speech functionalities central to this application. PlaySound plays the generated audio. The wavy lines indicate these libraries aren't installed yet. We'll address this next. Pip is Python's package installer. Sometimes specific versions of libraries are more stable. For PlaySound, version 1.30 has a known issue, so we'll install a previous version to avoid this. The notice suggests updating pip to a newer version. Keeping pip updated ensures you have the latest features, security patches, and bug fixes. Let's proceed with the command to update pip to the latest version as recommended. PySide-6 is a set of Python bindings for Qt libraries, which allows us to create a rich graphical user interface. This tool will enable us to build UI elements like drop-downs, buttons, and sliders for selecting voices, adjusting pitch, and more. The wavy lines indicate that we need to install the PySide-6 package. Executing pip install PySide-6 will download and install the PySide-6 library, allowing our application to utilize its UI capabilities. Once PySide-6 is installed, you'll notice the wavy lines are gone, indicating that the library is now available for use in your code. We'll define two variables here, one for storing the audio file format and another for setting a predefined default voice. These will assist in managing file outputs and providing a starting voice option. This portion of the code sets up the main application window, establishing a base for our UI elements to reside within. The init function initializes the TTS app class when we create an instance of it. Calling super.init ensures the QMain window parent class is properly initialized. These lines set the window title to PySide-6 edge-tts app and the geometry, position, and size of the window. Here, we set up a thread pool, allowing our application to handle concurrent operations without freezing the UI, which is crucial for responsiveness. These lines set up the main UI components like the central widget and layout, where all the other UI elements will be contained. These lines initiate the user interface setup and start loading available voices in the background. This function, init UI, is where we'll define the layout and interactive components of our application, such as buttons and text fields. These components form the basic elements of our application's interface: a status label, a combo box for voice selection, and a text edit area for input. We're using PySide 6 UI elements like sliders for adjusting audio rate and pitch. Sliders offer a familiar way for users to interact with variable settings. These are button controls that serve as interactive triggers for playing audio and saving the speech output. These lines establish the layout for our UI components using a form layout for dropdowns and a grid layout for buttons. These lines add widgets and activate the form and grid layouts, ensuring a structured and organized user interface. These lines complete the setup by adding all UI widgets to the main layout, ensuring each component has its place in the application window. This call disables UI controls initially until voices are fully loaded, ensuring errors aren't triggered by user actions while the interface is still initializing. PySide 6 connects signals, events to slots handlers. A worker in PySide 6 is a class that performs background tasks. Here, button clicks are connected to start speech operations. This function enables or disables UI controls based on the application state. Calling it allows you to manage user interaction conditions appropriately. This function updates the label for the rate slider to reflect its current value, providing immediate feedback to the user. Similarly, this function updates the pitch slider's label, helping users understand the adjustments they're making to the voice's pitch. This function manages background tasks, loading available voices by emitting a signal that populates the voice selection dropdown once complete. This function facilitates the generation and playback saving of speech by gathering user input and initializing a speech worker instance. Before processing, the text is checked for emptiness. If empty, an error is displayed to ensure meaningful output generation. This code retrieves the current voice settings and adjusts rates and pitches according to user input, readying them for processing. These formatted strings prepare the rate and pitch for compatibility with the edge-tts library, ensuring correct audio processing. Controls are disabled during audio generation to prevent concurrent user actions, and the status is updated to reflect the ongoing process. A speech worker is initialized to handle the audio generation and interaction task using the collected voice settings and text input. This function concludes by connecting worker signals, ensuring the UI is updated upon completion or error, and starts the worker. Next, we'll implement the slot for these worker signals. Slots are methods called in response to signals. This particular method updates the voice selection dropdown once the background worker fetches available options. The items in the dropdown are populated with user-friendly names and set by default to a predefined voice, reflecting the current status. These lines complete the slot by enabling controls and updating the status to ready, indicating the application is fully interactive. The following slots manage application flow. On speech finished re-enables controls post-generation, and update status maintains user feedback. The worker signals class defines custom signals related to background worker actions, notifying the main thread of events like error occurrences or task completion. The QRunnable class allows us to create separate thread-like processes for intensive tasks. Here, it's used for loading voices asynchronously. The init method of voice-loader worker sets up the worker, registering the past worker signals for later use in communication. The run method executes within the worker thread, fetching and sorting available voices asynchronously. Errors trigger signal emission to update the main UI. The speech worker class generates speech asynchronously while also managing file storage where needed. The init method in speech worker captures the necessary parameters for speech processing: text, voice, rate, pitch, and whether the output should be saved. The run method executes the main speech processing logic, either playing the text directly or saving it as an MP3 file while handling errors seamlessly. The try, except, finally block ensures the application manages exceptions gracefully, always signaling task completion to the main thread. If saving, the app creates a directory for MP3s, generating file names based on the current timestamp to ensure uniqueness and accessibility. If not saving, temporary files are created for immediate playback, ensuring no unnecessary files are stored. All potential exceptions during this process are caught and signaled, while the finally block guarantees the finished signal always emits. The Open Folder function demonstrates cross-platform ways to open File Explorer windows, ensuring users can easily access saved audio files. In Python denotes the module name. The main check establishes whether this script is being run directly, initializing our PySide6 application when true. Exiting with sys.exit ensures a clean shutdown. Right-click within the Name block to open the context menu, preparing to run your application. Select Run from the context menu to execute the main part of your application and observe its output. Congratulations on successfully building and running the application. This window is your finished product, and we'll explore its features next. The edge-tts library dynamically lists available voices populating this dropdown. Feel free to explore the different voice options. You'll find multiple voices in various languages and dialects ranging from US to GB English. Experiment with these to find your desired tone. The name following the locale code represents the specific voice model. Choose Ava as your voice for a natural-sounding output. Adjust the rate and pitch sliders to change the speed and tone of the speech. The rate affects speed, while the pitch modifies the tonal frequency. Type any phrase you want spoken aloud into this text area. This content will be processed by the text-to-speech engine. Clicking play will speak your entered text using the selected voice through your device's audio output immediately. The play and save button not only plays the text, but also saves it as an MP3 file. Click it to generate and store the audio. The application opens the File Explorer to show where the MP3 file is saved, making it easy for you to access and use your audio output. Great job finishing this tutorial. You've learned to create a text-to-voice app using Python, edge-tts, and PySide6. Thanks for following along.